Today, we are going to do applications of nonlinear functions. If you remember, we did do linear functions. Learning objectives are, at the end of this lesson, you should be able to identify and interpret quadratic functions, use quadratic functions to maximize revenue or profit and minimize cost, determine market equilibrium and break-even points for nonlinear models, solve practical economic problems using appropriate formulas and graphs. This should be formulae. Plural of formula is formulae, sorry. All right. Nonlinear functions in economics. A nonlinear function is a function, I'm sorry, a nonlinear function is a function whose graph is not a linear, sorry, it's not a straight line. In economics, in economic modeling, nonlinear functions are useful when revenue, cost, profit, demand, supply, or growth changes at a rate that is not constant. A simple linear model assumes a constant rate of change. Another nonlinear model allows the rate of change to increase, decrease, or change direction. For example, when the price depends on quantity, total revenue may become quadratic rather than a linear. So you will see here, you will notice with this formula, you will notice when you calculate total revenue, when it's dependent, sorry, on quantity, this is what's going to happen. Oh, sorry. So this is what's going to happen. You will have this. Your total revenue will be equals to AQ minus BQ squared. So you will, so this square makes this square, it makes the whole thing, the whole function to be a quadratic. So let's look at this first. Sorry, it froze. Okay. Okay. All right. So let's start with quadratic. Before we can do anything, let's start with the background of quadratic functions. A quadratic function is a function of a degree 2, and then this graph is called a parabola. So a degree 2, when you talk about a degree 2, we're talking about this square. So this square on the function makes the whole thing to be a quadratic. If it's a linear, your variable x doesn't have a square. It's just going to be x. So if you have a degree of 2, then the whole function is what we call a quadratic function, meaning that the highest exponent of a variable on your function is to the power of 2. So the general form of a quadratic function is written as ax squared plus bx plus c. A, B, C being your constants. So your A, your B, and your C, these are constants. This is what you call constant. It can be any number. This is what you call constant. And then this is what you call a degree 2. Okay, the highest exponent. And then we have what we call a quadratic formula. A quadratic formula is a formula that helps us to find what we call the roots. It helps us to find the solution of x in our function. So when you want the solution of x in your function, you use this formula, which is a negative b plus or minus a square root of b squared minus 4ac over 2a. Your a, b, c being these constants from your function. You'll understand when you do more examples. All right. So they're saying that, as I said, it is used to find the roots, often called the B minus formula. Others, they call it the B minus formula. So if you did a pure maths, you'll understand that, you'll understand actually this quadratic formula. But if you didn't do it, it's okay. It's not a problem. I'm aware that some of us did maths lit, but you'll see how we use it. All right. And then we have what we call a turning point. So a turning point is a turning point is a point that shows you the maximum or the minimum or the turning point of your graph. Because a quadratic function, when we draw the graph, it's a non-linear, it's not a straight line graph. So our graph looks like this. Let me just make an example. So if this is my Cartesian plane, sorry. So let's say this is my X, this is my Y. So your graph looks something like this. It's either it faces up or it faces down. So this is what we call a turning point. All right. So to find the point on your turning point, obviously this will be my Y and this will be my X. So to find the X value of this point, we use this formula. X is equals to negative B over 2A. Where do I get this? From my function, this function. Again, you will understand when you do an example. Right. So they're saying that a quadratic function has a minimum, which is A is greater than 0, or a maximum turning point. So the turning point, it either can be a minimum or a maximum. This one is a maximum because it's the highest. So the minimum one will look like this. Again, I'm just making an example. A minimum will look like this. Remember, you won't be asked to draw any graph. So this is just me making an example. So a minimum looks something like this. All right. So it has the lowest turning point. So actually this is yeah, this is the minimum. It's gonna face up, and then this is the maximum. All right. So now when you're I hope I did not mix these two up. Hopefully. Okay, when your A is greater than 0, your graph is going to look like this. It's gonna be a smiling, and then it's gonna be a smiling, yes. And then when your A is greater than, when your A is greater than 0, it's smiling. When your A is less than 0, your graph is going to be a sad graph. Those who did pure maths understand. Yes. All right. So when we talk about a less than and then the greater than, less than or greater than, let me explain that. A less than, it means that the value of A is going to be a negative. So if it's a greater than, it means that the value of A is positive. If it's A less than, it means that the value of A is negative. How will I know that? From the function. So it means that it's going to be a negative A x squared plus bx. But if it's a positive, it's going to be a positive A x squared plus bx. All right, I'm sorry for the interruptions. Okay, and then we have what we call a discriminant. You will notice that this discriminant is actually this part under the square root. It's b squared minus 4ac. This part is what we call a discriminant. Others, they use something like this. They call this a discriminant. All right. We use the triangle, but this is what you call a discriminant. In other textbooks, you'll see they're going to write it as as a triangle here under the square root. Okay. So this is what we call a discriminant. This part on our a quadratic formula. This is what we call a discriminant. So here they're saying that the discriminant is used in economics when solving quadratic equations that arise in revenue, cost, profit, or demand functions. They're saying it helps determine how many solutions break-even points or equilibrium points have a quadratic equation has. Yes. Okay. All right, so it's going to tell us how many solutions we're going to have. When I talk about solutions, it means that I'm talking about the X values. But because of now we are in economics, this X is going to change and become a Q. It's going to be a Q. What do I mean by that? Now let's see. What are we talking about? So we are saying that, remember here, we are maximizing profit and then minimizing cost, right? So we are optimizing quadratic revenue, profit, and cost function. So we are just using these basics to understand our revenue, profit, and cost functions because they're gonna change into quadratics. All right. So now in economics, this is what's happened. So the revenue function is going to change, right? It's going to be TR is equals to AQ squared plus BX plus C. If you can see, I just changed my quadratic formula into, the only thing that I changed is the Q. Remember we said that the quadratic function, it looks like this. It's something like AX squared plus BX then plus C is equals to 0. So you'll notice that the difference between these two is that this is the, instead of X, I wrote the Q's. So everything here is going to change. All these formulas, when we want to calculate the turning point, it's going to be Q is equals to. When we want to calculate the quadratic formula, it's going to be Q is equals to. I hope I make sense. This is just going to be Q is equals to, wherever I see X now, it changes to be a Q. So it's going to depend, what are we maximizing? Is it profit? Is it total revenue? Is it total costs? It's just going to depend on what is it that we are maximizing or minimizing. Right. And then they're saying that the profit function, we all know that it's P is equals to, we all know that it's P is equals to TR, total revenue minus total cost. So when we are optimizing, it's going to be P profit is equals to AQ squared plus BQ plus C. Because of there's a square, it means that we're dealing with quadratic everything. And then the total cost function also is just going to be in this form. But then let's see how it goes. And then here I'm saying that A and B, all right? Quadratic optimization, use the turning point formula. X is equals to negative B over 2A. Okay, this is supposed to be Q. All right, this is going to be Q because now we are optimizing. Okay, so this will be Q is equals to negative B over 2A. All right. So now let's look at the example. We have an example here. The example says that a monopolist has the demand function P is equals to 100 minus 2Q, where P is the number, sorry, is the selling price and then per unit, and then Q is the number of units sold. All right, so that's our example. So now the first question says, write down the equation for total revenue. So we all know that the equation for total revenue, when we want to calculate total revenue, we are going to say TR is equals to P times Q. So this shows that for you to understand this, you must firstly understand your first lesson and second lesson. All right. So this will be equals to our P is this. We are given P. So this is going to be 100 minus 2Q. And then times our Q. And then this is equals to, then now we multiply. We distribute. All right. So it's Q times 100. Q times 100. We are going to have 100Q. And then minus 2Q squared. So this will be our total revenue. All right. And then now we move on to the second question. All right. So you'll see that, remember I said that if it's a square, it means that if we have a squared, it means this makes the whole function a quadratic function. These two here, this two makes this function to be a quadratic. So it means that I can apply the quadratic formula, I can apply everything. All right, depends on what the question wants. Okay, now let's move on to number B. So number B says determine the number of units that needs to be sold to maximize total revenue. And then when you are done, calculate the total maximum total revenue. All right. So now we all know that okay. Before I can continue, I want you to note that, please note that total revenue is a maximum at its turning point. Total revenue is a maximum at its turning point. If they say calculate the total, Sorry, if they say calculate the maximum total revenue, it means that now we are going to start with, we have to look for the turning point if you want to calculate the maximum. All right. So now, first thing we have to calculate, number one, they said they want, the first question they said they want total, sorry, they're saying determine the number. They want us to determine the number of units. All right, so let's determine the number of units. So when you determine the number of units, it means that we are going to calculate the turning point. So it's going to be Q is equals to a negative B over 2A. All right, so for us to calculate this, we need the function for total revenue. So our function for the total revenue, TR is equals to 100 Q minus, could you all right, sorry about that. So it's going to be TR is equals to 100 minus 2 Q squared. So remember, this is our total revenue function. So this will be, so it means that now we need to calculate the number of units, sorry. So my number of units, the formula needs, the number of units, the formula needs my A, B, C. So Q is equals to, okay, let me just name it. Sorry about that. Let me name it the number of units. So the number of units, this is how I'm going to calculate it. So it's going to be Q is equals to negative B over 2A. So my A is equals to, anything that is next to a square is my A. Remember that the total revenue formula, it's supposed to be TR is equals to A Q squared plus BQ, then plus C. And then this will be, if I write this in this form, I'm going to have negative 2Q squared plus 100. So it means that I am going to have negative, then I substitute my B. Okay, I didn't write my B. Sorry about that. So my A, my B, so my A. Okay, here, my A is equals to negative 2, and then my B is equals to, this is Q. My B is equals to 100, and then it means my C is 0. So I'm just going to substitute everything here. So I will have negative. My B is 100 over 2. Then my A is negative 2. And then this will be equals to, when we use our calculator, we are going to have 25 units. So this will be 25 units. So I answered the first part of the question. And then the second part of the question says calculate the maximum total revenue. So when I calculate the maximum total revenue, remember we said that the maximum total revenue is at its max, total revenue is at its maximum, where the graph is turning. So the maximum, so it means that we need the turning point, right? So it means that my total revenue, remember total revenue is equals to, our total revenue is 100Q minus 2q squared. So when I calculate, I'm going to substitute the 25 units for me to get that. So it means that you cannot calculate this at its maximum without calculating the turning point. So you first start with calculating the turning point. Even if they did not ask you to calculate the number of, you need to calculate the turning point, even if they didn't ask you to calculate the number of units. And then we are going to have, now we use our calculator, 100 bracket or times minus 2 times 25 squared. We are going to have, the answer will be 1,250 rand. So that's the maximum total revenue. That's how we calculate it. Okay, let's do another example. So this example, they're saying that a firm has a total cost of 200 plus 3Q, and the demand is P is equals to 107 minus 2Q. They're saying write down the total revenue function. So they're saying must write down the total revenue function. We all know that total revenue is equals to P times Q, and now we substitute our P. We have 107. So 107 minus 2Q, and then times Q. And then we are going to say we distribute now. Remember, you multiply this with that. So it's 100 times this times that. We are going to have 107 Q minus 2Q squared. So that's our total revenue function. And then now we move on to B. So B says determine the profit function for the firm. Oh, sorry. Profit function for the firm. We are going to firstly write the formula for profit. We all know from our previous lesson, profit is equals to total revenue minus total cost. And then this will be equals to, remember, our total revenue, we already calculated it, is this. It's 100. It's 107 Q minus 2Q squared. Then minus our total cost. We were given the total cost, which is 200 plus 200 and 200. What am I writing? Okay, sorry. 200 plus 3Q. And then this will be equals to, then now there's nothing to multiply with this bracket, so it stays the same. It's 107 minus 2Q squared. And then now we distribute this negative here. If you don't understand, there will be a total loss. Okay, and then this will be a minus also, 3Q. And then now after this, we add the like terms. So these two are like terms. These two are going to be like terms because they both have Q's. So you take your calculator, we say 107 minus 3Q. Then our answer is going to be 104Q. And then negative Q squared, there's no number with a Q squared. So you write this one here. And then we have minus 200. There's no number without a Q. It's only 200. So that's our profit function. So this will be our profit function. All right. And then now let's move on to C. C, they're saying determine. Okay, let me just try to move this up. If I'll be able to. Okay, let me try. Just want to. Oh, okay. Sorry. Okay. Okay, let's see. All right. So C, it says determine the maximum profit. So the maximum profit, we are going to, remember with the maximum, it means we have to start with the turning point. Every time they say maximum something, we are going to have to find the turning point first. So remember, our profit, remember we're maximizing profit now. Okay. So our profit, we calculated it. We said is P is equals to 104 Q minus 2Q squared minus 200. So I'm going to write this in order, in the quadratic order. So I'm going to start with the one with 2Q squared, then plus 104 because 104 is a positive, and then this is minus 200. And then, so it means that here, remember the turning point, you need the A, B, C. So my A is -2, my B is 10, and then my C will be -200. All right. And then now we calculate the turning point first. Remember, to maximize, you need the turning point, the number of units first before you can maximize. So I'm going to start with the number of units, which is Q, firstly. So I'm going to calculate Q is equals to -B over 2A. Then I substitute. And then this will be negative. My B is 10. Then over 2. Then A is -2. And then when we use our calculator, our answer is going to be, we are going to get 26. So it means that we have 26 units. And then now add our maximum. So now we need to calculate the maximum profit. So maximum profit will be P is equals to, then you use the function of our P. So it's going to be -2. Wherever we see Q now, we put, wherever we see Q, we put 26. All right. Wherever we see Q, we put 26. Then plus, this was 104. Then I'm going to put 26 again inside the brackets. And then this is minus 200. Okay. So our answer is going to be 1,152. So that's our maximum profit. So remember that our profit function is P is equals to -2Q squared plus 104Q minus 200. Just in case you were asking yourself, how did we substitute here? So here, everywhere I saw Q, I put 26. Where do I get the 26? I calculated the number of units at the turning point. So this is a turning point formula. All right. And then now we move on to the next part. All right. So with this question, there will also be a minimizing. It's the same thing. We do the same thing. You need the profit function to maximize. You cannot maximize without the profit function. And then to maximize, you always calculate the turning point. And then now let's move to market equilibrium. Market equilibrium, so they're saying that market equilibrium with nonlinear. Remember, we did the equilibrium with the linear. Now we are doing the equilibrium with the nonlinear. So they're saying that market equilibrium occurs where the demand price equals the supply price. We all know that. Equilibrium, I said we equate. So for nonlinear functions, equilibrium is still found by solving the simultaneous equation, which is PD for demand, P supply for a supply. So they're saying that then we substituting the equilibrium quantity into either formula. Okay, we all know this part. Sorry about that. So we have an example that's saying the market, demand, and supply functions are. So we have those two functions. And then they're saying determine the equilibrium quantity and price. So you'll notice here, the only difference that we have is a square because we are dealing with a quadratic. With the linear, there's no square, but the procedure is we're still doing the same thing. All right. So we are going to start by equating. We all know that. So we all know, I say PD is equals to PS, and then now we substitute. Our PD is Q squared minus 10Q plus 25, then is equals to Q squared plus 6Q, then plus 9. And then now after this, we, after this now, we move everything to the left-hand side. then we're going to do the like terms part. Okay, so this is q squared. I'm going to take the q squared. The other q here is going to be negative q. I took the one from my left. Remember, when you move a number from your left to the right, so from your right-hand side to the left-hand side, if it jumps an equal sign, it changes the sign. So this is q squared that was already on my left. Then I take this one to the right, it becomes a minus. All right, and then this is negative 10 q. And then I'm going to take the number with the q, which is 6. So it's going to be 6q. It becomes a negative. It was a positive. All right, and then I have a 25, which is plus 25. Then I move the 9 to my left-hand side, becomes a negative. The equal sign is still there. Please don't leave it behind. And then there's 0, because we moved everything to the left. Now we add the like terms. Q and Q, it's a 0. So these two, they're going to give me a 0. All right. And then now I'm going to say negative 10q minus 6. The calculator gives me negative 16q. Then it's equal, negative 16q. Then 25 minus 9, I'm going to get Okay, my pen has a low battery. It's going to give me a 16. Then this is equals to 0. All right. Then now I need to solve for q. So I'm just going to take this to the left-hand side, the right-hand side, because I want to solve for q. So I will have a negative 16q is equals to negative 16. And then now I'm going to divide both sides by negative 16. And then when I divide, my answer is going to be q. Remember, these two are going to cancel. This is 16, by the way. Okay. I hope this pen doesn't switch off now. Okay. And then q will be equals to a 1. So I have my quantity. So this is 1 unit. Then it means now I must solve for my quantity price. Okay. So when you solve for the price, we are going to have the price is equals to. So remember, you choose any formula. Okay, let me choose this one. Okay, this is q squared minus 10q. Anyone will give you the right answer. Okay, so now when we choose this, I'm going to substitute wherever I see q now, I am going to put 1. So it means this will be 1 squared, then it's minus, and then 10, wherever I see, I put 1. And then this is plus 25. So when we use our calculator, the answer that we are going to get for the price, we are going to get 16. All right, so what does it mean? So therefore, this means that, quantity. Okay, let me just write it here because it keeps on moving. Okay, so this means that, therefore, quantity is 1 unit, and then it means that, and equilibrium price will be 16 rand. Actually, let me write it here because it's delaying me. Okay. When quantity is 1 unit, then the equilibrium price will be 16 rand. That's it. And then now let's see the nonlinear for break-even analysis. Break-even analysis occurs where the total revenue equals the total cost. So we did this the last time. So they're saying when total revenue is quadratic, there may be 2 break-even points. So it means that you're going to have 2 solutions. You might have 2 solutions at break-even point for a quadratic, because now we're dealing with a nonlinear quadratic, same WhatsApp group. Okay, so they're saying that profit is positive between the 2 break-even points when the revenue curve lies above the cost curve. Okay, all right. So we have an example here. It says that it says that a product has a fixed, or the formula that we use for, we know total break-even point, total revenue is equals to total cost. We all know that. A product has fixed cost of 30 rand. We all know that that's a fixed cost, FC. We did this, remember? And then the variable cost per unit is cost of 2 rand per unit. So this is VC. So remember VC, this will be 2Q. We did this. C times VC is equals to C times Q. We did this, remember? And the demand Q is equals to, so we're giving demand in terms of P. So they're saying determine the break-even quantities. Okay. So they're saying write down the total revenue and, okay, so I think I was supposed to remove this question because I decided to make this longer so that we can all understand. Please excuse that part. I just wanted to make this question longer so that you understand instead of answering two things in one. Okay, so the first part says write down the total revenue and the total cost. So we need to write the total revenue and the total cost. So that's saying our answer must be in terms of Q, in terms of Q. So when we say in terms of Q, it means that now I need to change this. This is in terms of P. This one is in terms of P. In terms of P, it means to make P the subject of the formula. This is in terms of P. All right. So now I'm going to make it in terms of Q. So let's do that first. All right. So we have Q is equals to 65 minus 5P. So I need to solve for P so that my answer can have a Q. All right. So we are going to move this to our left-hand side first. We exchange. So I'm going to have a 5P and then it's equals to 65. It became positive because it jumped an equal sign. Then I take the Q to that side, it's going to be a negative. So this will be negative Q. All right. And then after this now, I am going to divide both sides by 5 because I want my P to be alone. So when we divide, remember here there's always a 1. Let's not forget that. Then we are going to divide both sides by 5. So divide by 5, divide by 5, divide by 5. And then this 5 and this 5, they're going to cancel because 5 divided by 5 is 1. So this will be P is equals to, then we divide 65 by 5, we get a 13, then minus 1 over 5 is going to be 0.2. Then this will be Q. This answer is in terms of Q. When we say answer in terms of Q, this is what we mean. This is in terms of Q. I hope this makes sense. In terms of Q. All right. And then now let's calculate what they want. They wanted the total revenue and the total cost. So total revenue is going to be equals to, we all know it's P times Q. So our P is, we have it here, it's 13 minus 0.2 Q. And then this is times my Q. And then we distribute. I already taught you how to do this. Distribute this times that, this times this. And then my answer will be 13Q minus 0.2Q then squared. That's the total revenue. And then the total cost, our total cost, we all know that total cost is equals to FC plus variable cost. So our fixed cost is, I already told you here, fixed cost is 30 from the statement. Then plus our variable cost is 2Q. I already showed you up there. That's our answer. Now let's move on to B. So B says determine the break-even quantities. So we are looking for Q, break-even quantities. So when you're calculating the break-even quantity, remember break-even, we said total revenue is equals total cost. Don't forget that. I already showed you the formula. Total revenue is equals to total cost. For break-even points, we're looking for the break-even quantity. Okay, so we equate. So our total revenue is 13Q minus 0.2Q. Then this will be equals to, our total cost is 30 plus 2Q. And then now we solve. This is a square, sorry. Now we solve. So let's move everything to the left-hand side. We are going to have 13Q. Then I move this one with the Q to my left-hand side. It's going to change the sign. It becomes a negative 2Q. And then I have minus 0,2q. If I write red, just know that something changed. This one is a 30, negative 30, then is equals to 0. And then now, like terms, we are going to have, I'm going to start with, okay, 13 minus is going to be 11q. And then we have negative 0,2q squared, and then minus 30q is equals to 0. 30, sorry, not 30q. Now I'm going to write it in a standard form of a quadratic form. We start with the one that is in a square, so this will be negative 0,2q squared plus 11q, and then minus 30, then it's equals to 0. So when in this form, it means that when it's in this form, it means that my A is negative 0,2, my B is 11, and then my C is negative 30. Now I can use a quadratic. Remember, when you have a square, that's when you use a quadratic formula to solve for the roots or to solve for the unknowns. With a square, it means that this square, it means that we need to use a quadratic formula. I already showed you the quadratic formula. To solve for the roots, we are going to use the quadratic formula. Quadratic formula, remember, is changing. It's not x is equals to, but it's going to be q is equals to a negative b. Why am I writing it like this? It is negative b plus or minus, if you remember. Plus or minus means that you're going to have two solutions. This will be b squared minus 4ac and then over 2a. All right. And then now we are going to substitute our a, b, c. We're going to have two of them. So I'll show you what I mean. So this will be q is equals to negative a negative b. Oh, negative b, our b is 11. 11. Then this is plus or minus, then the square root of b squared minus 4. Okay, I'm just doing this brackets because I want to substitute with the red. And this is 2. Okay, so b is 11 minus 4a. Our a is negative 0,5. Okay. Negative 0,2. Why am I saying 0,5? And then times our c is negative 30. Okay, I hope I did not make a mistake. If I did, please do forgive me. Okay, so this, our a is negative 0,2. All right. B squared minus 4ac. Okay. All right. So this is going to be two answers. Guys, plus or minus, it means you have two answers. Plus or minus, we have two solutions. So let's see. We have, it's negative 11. Then I solve everything under the square root. So this will be the one of a plus that I can show you. When you use your calculator, under the square root is going to have a negative, sorry, 774. Then over negative 0,2 times, it's going to be negative 0,4. Then we say or, because we're going to have two answers. The other one will be q is equals to negative 11. Then minus, plus or minus, this is what I mean. Minus square root of 97 over negative 0,4. All right. So our answers will be, our q here will be equals to, when you use your calculator, you're going to get the answer that is approximately 2,9, or our q will be equals to 52,1. All right. So what does it mean? So this means that, what was the question? It was saying that a product, okay, has a fixed cost. Okay, so this means that whatever this is a company or what, it breaks even at approximately 2,9 and 52,1 units. It breaks even at these 2 points. So it means that it earns profit between these two. All right. So between, that's when it's going to add n profit between these two. All right. So for this section, in your assignment, we only focus, for this module this semester, we only focus on quadratic function. We only focus on the quadratic function. We're not going to focus on the hyperbola, exponential, but you can also go through them for your knowledge, because we also deal with cubic functions, all right? We're not going to deal with cubic functions. It's only going to be quadratic. So you can go through cubic, you can go through exponential, you can go through hyperbolic for your own understanding. But please note that we're only going to focus on quadratic. Okay, thank you.